This is our video for CVM 10 about checking multiple representations, and you don't have to turn to this, but I want to show you one thing. We've seen this phrase, multiple representations, before. If we go all the way back to page 16 in our notebook, checking multiple representations of force, remember we had to make sure that the number of arrows in the force diagram is the same as the number of lines connected to the object of interest in the system diagram. The idea was these were two different representations, two different ways of showing what was going on in a situation, talking about interactions, and we needed to check that they were consistent with each other. If they weren't consistent, we knew that something was wrong and we had to fix it. So this idea is coming up again, but we have a lot more representations to think about now. Descriptions with words, position versus time graphs, motion maps, these are all examples of representations. These are specific ways to describe what's going on, and if you're given one representation, it's possible to fill in other representations also. So, this is the key. When analyzing motion, check all representations against each other. If you find things that are consistent, you'll need to revise these things until they agree. You've already been doing that. If you've been playing that graphing game and making your calculations, checking your calculations against what you know works for the graphing game, that's an example of what we're talking about here. So I want to give you some suggestions of what you can do to check multiple representations. We're going to check back and forth with CVM 9, so make sure that your notebook is open like this. That is, you want to have both pages of the notebook open. And if you don't have all of CVM 9, including this description, you want to make sure that you have all of that. So make sure that you have this motion map perfectly written down, and make sure that you have this table, graph, and description perfectly written down. If you need to, you can pause the video and get that right now. First thing, we want to say one example of how to check multiple representations is to check that the initial position on a graph, motion map, and description all match the t equals 0 row in a data table. So for example, we're going to look at what this looks like in CVM 9. All are 100 centimeters. To see what we mean here, I'm going to take this symbol, this three-line star, and I'm going to point out where I see that this is the case in our example in CVM 9. So, for example, the initial position on the motion map is 100 centimeters. I put this same symbol here to make sure that I understand that like this is referring to that. I put this same symbol here. The first row of the data table shows that that initial position has to be positive 100 centimeters. I put this same symbol here to show that that same initial position is consistent across all three. And look down here in the description, I'm going to put that three-line star by this also. I'm checking this initial position in 4 different places to make sure that it's consistent across all those places. So let's do this for a couple more examples. And make sure that you're using these symbols on CVM 9 so that you can refer to those in the future when you see what we mean by multiple representation. This time we're going to use a triangle. And we want to say check that the direction of every motion map arrow matches the slope of the graph. So for example, in CVM 9, arrows start pointing positive. And the graph has a positive slope. I'm going to use the symbol positive here. That's not a T, that's a positive if you want to put a circle around it. That means the graph has a positive slope when you start out. So I'm going to use this triangle here and point out what I'm talking about here. These arrows are pointing in the positive direction. So I'm going to put that triangle here to draw my attention to those arrows pointing in the positive direction. This is that positive direction here. And this slope is a positive slope. You could even make a note to yourself if you have trouble. Remember, this is a positive slope on this section of the graph. We need to make a connection between which way these arrows are pointing and this positive slope. We could also make a connection between which way these arrows are pointing and this negative slope. If you want to help point that out too, you can. Down here in the description, we know that Miss Gabriel moved in the positive direction. I'm going to put a triangle there too next to the word positive because this description is telling us the same thing that the graph and the motion map are all telling us. One more example of what this looks like. I'm going to use a circle with a dot in it for this last example. We want to check that the velocity, parentheses, slope, matches the increase / decrease in position each second, actually, sorry, I'm going to erase this word and. Each second in a data table and matches the gap between dots in a motion map. So, for example, in CVM 9, the slope changes to negative 100 centimeters per second, and the positions in the data table change by 100 centimeters each row. So again, I'm going to use this circle with the dot symbol to check that at every moment. I'm going to say in the graph, I can tell, circle with a dot here, the slope equals negative 100 centimeters per second. I can tell, this is important, I'm going to point this out. In the data table here, I can tell that this is a negative 100 centimeter change. This is also a negative 100 centimeter change. This goes from 250 to 150, 150 to 50, 50 to negative 50. That is, it's changing by 100 centimeters each row. We're pointing out that that's what velocity means. This change second by second of 100 centimeters in the negative direction, that's what negative 100 centimeters per second as a velocity means. And we could actually have, we want to check that the gap between these dots is also negative 100 centimeter change. That is the information contained in the separation between these dots and the information in the change in the table. That's all connected to what this slope is telling us. So when you use this in the future, these are just 3 examples. There could have like hundreds of examples of things that we're checking on the multiple representations, but on your next test, you're going to need to actually do this type of check and describe that you've done this type of check. These symbols are here to help you refer to this example as something that clarifies to you what we mean when we say checking multiple representations.